All right. Hey, everybody. I hope everybody's having a wonderful 3-day weekend. I got a few questions here on question 147. So I want to make sure you understood what to do with that. I said on Friday, whenever they ask you to describe a graph or say something about graph or answer things about a graph, just follow Miss R. That's it. Miss with three S's, Miss R. The notes that we had on Friday, because let's just all deal off this one thing. It's sort of like, well, we're all describing different things, or we try to describe the same thing again and again and again. And it really is just these six things at this point. So, anyways, just use Miss R. We don't have to worry. We haven't done any learning logs or anything like that. What's a learning log? Well, I haven't explained that at all yet. But anyways, you use your list of graph investigation questions. You're just going to use Miss R to answer this question. Okay, so if I were answering this question and I had to describe this graph right here, which is an absolute value graph of this function here. We haven't graphed an absolute value graph yet, but we did look at one and describe one on Friday. And you don't really need to worry too much about how this thing exactly gets graphed. But anyways, there's the equation right there. If I were to describe this one, here's how I do it. I just start with my M. Okay, I start with my M and describe that first. Minimum, of course. What does it stand for again? Or M, what does it stand for again? I kind of gave it away there. Minimum or maximum points. This one here looks like we're going up. Like we got these arrows right here and right here. So this one's shooting up, right? Shooting up and goes and go up infinitely, right? Infinitely here. So it's not gonna have a maximum point, but does it have a minimum point? Does it have a minimum point? Is there like a certain point where it's the whole function right here? If I just want to trace over it, just to make sure you see it, okay? Because it can be kind of confusing when you see the x-axis here and the y-axis here. The x-axis and y-axis, your vertical axis and your horizontal axis, aren't actually part of your function, right? It's just sort of organizing where all the points go, all the input-output relationships that we have here. So anyways, this is going to have a minimum point right here. What do we call that? We call that the vertex. So I'm going to go ahead and circle that so you can see it there. You know what I'm talking about, hopefully. There's our vertex. Okay, so for minimum points, we can use that vertex. Okay, so minimum point. So we have a minimum point at that vertex. Minimum point at, looks like we're at -2. Oops, sorry, -2 for x value. Okay, x-axis, we go over here. This is 1, 2, 3. Look, we see +3. This is -1, -2, -3. Looks like this is -3. So it looks like we're at -2. And then for our y value, it looks like we're just one below the x-axis. So if this is +1, 2, 3, this is -1, 2, 3, and we're only one below, so it's -1. So we have a minimum point at -2, -1. Oh, interesting. We see a +2 there and a -1 there. Okay. There is actually a connection between the equation and where that vertex is going to be. We don't really need to worry about absolute value functions in algebra 1. So, right, maybe you notice something, but it's not a big deal if you haven't yet. Okay, I, what does I stand for again? I is increasing or decreasing. Okay, so this is a little bit tough here. I definitely, heard you guys kind of not really too sure about this one. So we read graphs in terms of what they're doing, how we read from left to right, right? As x values are increasing. So I might write down that down there. As x values, so I, right? I stands for increasing or decreasing, okay? But we always think about when the x values are increasing, right? From left to right, what's happening, okay? As x values increase. Okay, that's always how you kind of think about increasing or decreasing. Let's start at our lowest x values. And of course, our lowest x values are over here because this goes to -infinity, actually, right? -infinity over here. And our x values are biggest over here. This is +infinity if we headed that way, infinitely forever. So anyways, let's trace the graph, right? Say trace the graph from left to right as x values are increasing. Okay, we'll start as farthest way as we can, our most negative as we can, and it's only really -5 or so. But anyways, we trace the graph, and what's happening to my pencil here? What's happening to my pencil as I trace? It's dropping. It's dropping. Okay, so we are decreasing here, decreasing. Okay, as x values are increase, our y values are decreasing. Okay, y values decrease. Okay, it decreases, so go down, it decreases down, and whoa, we hit that lowest point, the vertex at -2, 1. So the y value decreases until we get to -2, -1. So you might just write the whole coordinate down, but I'll write what the x value is, right, of when it's going to change directions until x equals -2. And then once we start like -6 or so, we start at the lowest x values we can. We're going from left to right. Once we hit x equals -3, start shooting up. Start shooting up right there. Okay, so then we start increasing. This is what I look for here when you're going up and to the right. Up and to the right. There we go. It's mirror image for me. Up and to the right. That means it's increasing, and that's what I'm trying to write here. It's very small, so I doubt that you're able to read it here until x equals -2. Okay, then it increases. And what some people said on Friday, right? We're very savvy people on Friday said that, we can say how it's increasing or how it's decreasing. Some people describe slope in this case. Yeah, you can get a slope of that right there. You get a slope of this here. We'll kind of cover the slope in chapter 2, so I'm not expecting you to get slope at this point. But one thing that you might have noticed in the past is sometimes things grow linearly. Okay, what that means is at a constant rate. And these are, kind of look like lines. Okay, kind of look like lines. So that means it's increasing at a constant rate and decreasing at a constant rate. So you might want to say something about that, whether it's increasing or decreasing at a constant rate, or if it's increasing more slowly as time goes, or more quickly as time goes, like a quadratic would grow more quickly as we got further away from the vertex. Okay, then it increases at a constant rate. Okay, if you want to report the slope, good for you. But if not, no worries at all, at a constant rate. All right. So that's MI, and then we get the fun stuff. We get to the three S's. Remember the first one. So S, S, and S. You got to kind of remember those. Got to kind of think about them, okay? First S that I typically do is shape, okay? And what would we say about shape? Well, we usually try to stick a shape with a letter from the alphabet. This one's pretty easy. This is a V, right? If I have an arrow here, it's going to keep going forever this way and keep going forever this way. So it's a giant V. Shape is a giant V, but we might just say V, V-shaped. V-shaped, V for value. They're V-shaped graphs. All right, next S, we keep going. This is probably your longest problem right here, huh? Five or so minutes or so. Me explaining it this video would probably be more like 10. Okay, next S, so we have shape. This is going to have to do kind of with the shape too, with S here, and that is symmetry. Okay, symmetry here. So even though this left side of the vertex looks different than the right side of the vertex, what did I say? We have an arrow here. They had an arrow when we looked at it in the graph. This keeps going forever, right? Keeps going, extending infinitely like this. This can extends infinitely like that. So ultimately, right? Because remember, there's for this function here, we can put in any value of x, right? Any number has an absolute value, right? It's not like the square root function where we input a negative for square root, we don't get an output. So any number has an absolute value. Any number has a certain distance from zero. Remember, absolute value is distance from zero. So anyways, we can put in anything. That's the reason why I know with the arrows there extends forever. So what does this graph look like? Does it look like symmetry? Yeah, it does. Totally looks like symmetry. Look, if I folded it over the vertex like this, okay, this side of this line here, and then I fold it over this line of symmetry right here, I'd be right over this ray right here, So yes, there is symmetry. Okay, yes, symmetry. And you might want to say something with a line of symmetry. Line of symmetry, you might say it's a vertical line through the vertex. Another thing you can use to describe lines of symmetry as well is this. You can say which x value it goes through. So here, notice this here, a line of symmetry like this. Remember, this is what we fold over, fold this side, and we fold it over this line. We'd be directly on top of this one. That's why we know that this is symmetrical. So anyways, this line of symmetry, right? If we folded this point, would match that point. This point up here, folded over that, would match that point up here. This point here, folded over this line of symmetry, would match that point over there. So anyways, these vertical lines of symmetry, if you notice here, what's the x values for this entire line? Like if I had to picture this point, which would be the point of reflection or the point of symmetry for that point, and it reflects over to this and it's over here. This coordinate, well, it have a y value of around 5. But what's its x value? Its x value is -3. So what you can say, right, if you want to be a little advanced with this here, is you can give the x value that line of symmetry is going through, okay? Line of symmetry at x equals 3, okay? And we're going to know that is a vertical line, right? That is a vertical line. That's actually how we write equations for vertical lines, is that we just say what the x value is, okay? Because vertical lines only have one x value. It's what your x-intercept is right here. So if you have a vertical line, the equation is you just say what the x-intercept is, and all of the points would also have the same x-coordinate as the intercept has. Okay, confusing, yes, a little bit. That's why we'll practice horizontal lines like this, horizontal lines, and vertical lines like that, because they have kind of special equations, which we'll talk about in chapter 2. Next one is S. So we have shape, symmetry, and what's the last one? Special points. Okay, special points here. So we'll get special points on this one. So we do have some special points. Okay, you might want to talk about the vertex. We didn't call it a vertex, we called it a minimum point here in the M. Okay, special points, we can talk about the vertex at -2, -1. What else? What are the things that we usually talk about too? We talked about them definitely with quadratics, with parabolas. We were focused on this. We are focused on where it hit the x-axis. That's right. We have the x-intercept. Do we have a y-intercept here? Yes, we have a y-intercept. So special points kind of mean like the vertex and then the intercepts, right? The intercepts here. Okay, so we have here a few special points. We have, looks like we have an x-intercept here, another x-intercept here. Like a lot of times there are two x-intercepts. It's a little tricky. How many y-intercepts though? Just one. Okay, if it's a function, it's actually only going to have one y-intercept, and we're going to learn what a function is this week. Okay, so we got those 3 points. Those are special points. So let's write them down right now. Okay, so we have x-intercepts. We have 2 of those x-intercepts, and we got those at -4, 0 is what I see, and I also see -1, 0. All right, and wait, -4, not -4, -3. Yeah, -3, 0. That's what I have here. This -3 is a little bit offset, but if we go -1, 2, -3, that's where this graph is crossing the x-axis, the horizontal axis here. Okay, y-intercept, that's a little easier for me to find. If this is 0, 0, and I go up 1, I'm scaling by 1s, that's 0, 1, okay, is the y-intercept. So I have y-intercept where that graph, like the V-shaped graph is, crosses that axis. That vertical axis is when the vertical axis, that coordinate is worth 1, and that, of course, is the y-axis. So it's 0, 1, our y coordinate goes here. X comma y, right? X comma y is how we write our vertex, our coordinates, not y comma x, not y comma x. It's always x comma y. X, your input variable, is more important than your output variable, because sometimes you don't have outputs and it's kind of confusing. But anyways, so there we go. We have M.I.S.S.R, 3 S's, and then finally R. Okay, so hopefully you got this on Friday. I think this is a good homework problem because this is kind of like an exit ticket from the notes we took on Friday. Did you kind of take notes? Did you kind of get it, right? To kind of sort of check yourself, or do you need to find help? Okay, so maybe you're watching this video, maybe you're getting that help now. But hopefully you got it Friday without watching this video. If not, you do the right thing by watching this video. Of course, email me if you have any questions. Last one, restrictions. Okay, restrictions here. Well, we already kind of talked about any number has an absolute value, right? What is absolute value? Well, absolute value is a number's distance from 0. Okay, so if you're negative, you have a positive distance from 0, because distance is always positive. If you're negative, right, if you're negative, the absolute value is positive. If you're positive, your absolute value is also positive, because you have a positive distance from 0. So anyways, there are going to be no inputs here for x, because any number x has an absolute value. So no restrictions for x. What about y? Okay, well, absolute value, right, makes things positive. Okay, so this thing here, if I looked at this actual equation, x plus 2 has to be positive, right, because that's a number plus 2 to that number. You find the absolute value of that number, right? If we read this here, this x plus 2 is grouped together within the absolute value. So a number x plus 2, okay, and then its absolute value has to be positive, and then there's a -1 on the outside. So our minimum point was at -2, -1. That means our outputs kind of start there, okay? If x plus 2 has to be either 0 or positive, and we're taking 1 away from it, our outputs are never going to be lower than -1 we have here, okay? So your vertex is kind of your guide to answering this restrictions problem. All of our y values, well, they got to be positive because x plus 2 has to be positive. The absolute value of x plus 2 has to be positive, but they could also be negative because x plus 2, if x were -2, right, -2 plus 2 is 0, then we'd have the absolute value of 0 minus 1. So they could be as low as -1. So the restrictions for y is that no restrictions for x, but y needs to be at least -1. Or you can say all y values. All y values are -1 or larger. And there you go. You fully described the restrictions here. Okay. Message me if you have any questions. Again, you're not using a list of graph investigation questions from Learning Log. No, we didn't do that. We wanted to clean things up. I had a great student a few years ago who came up with this acronym here, M.I.S.S.R. And eventually it's going to become Ms. Doctor. Right? Remember that? What does the D stand for? That came up, I think, in third block. They figured out what the D was, or they got me to say what the D was. But M.I.S.S.R. for now. Message me if you have any questions. Thanks for watching, guys. See you guys tomorrow. Bye.